Hello, welcome back to another edition of Mr. Walker's Apes. Continuing along with our geology unit, we're now going to move into a little bit on geology, but more about mineral resources. Okay, so we're talking about the non-renewable natural capital that is minerals, um, and a little bit about mining and techniques that we can use to mine the minerals. So first, mineral resources are, just it's a mineral. It's a concentration of a naturally occurring material in or on the Earth's crust that can be extracted or processed for a useful material at an affordable cost. This would be diamonds. Okay, diamonds are a mineral. We use those not only to look pretty in jewelry, but in industry to cut things. Like you can get a diamond-edged metal cutter or something like that. Um, so again, it has to be affordable. We don't want to spend a lot of money getting these things. Ore, okay, the definition of ore is just a rock containing a lot of the mineral. Uh, in other words, it's profitable. Okay, ore is the profitable rock. You've got high grade and low grade ore, where high grade has a lot of it, low grade has not so much of it. Okay, so here's some things with mineral production in the U.S. 1900 to 2000, so the last century. Um, so we've got, starting in 1900, not that much mineral production. Okay, this is in metric tons, so 1,000 kilograms, um, which is about 2,200 pounds. Okay, not that much. Since then, we've really come a long ways. Um, use some critical thinking here. Uh, you know, why? Okay, why have we gone from less than 200 metric tons per year to almost 3,500, probably over 3,500 now, just in the United States? All right. So, and look, we've even got recycled stuff. Okay, we started recycling right after the birth of the new environmental age. So think about that. All right. Now that you've hopefully thought about it, if you haven't yet, pause and think about it. The biggest reason, stuff. Stuff. We have way more stuff now, okay? Back then in 1900, everything, candles, very few light bulbs, small houses, no air conditioning, wood stove, no refrigerators, all that stuff. You know, Now we've got everything. There's not a lot you can't get now. So of course we're going to need more minerals. We're going to need more natural capital in order to do those things. And of course you look here, during the Great Depression, people buy less stuff, so you need less minerals, fewer minerals. World War II, you need to make more tanks, you need to make more airplanes. You're going to peak, okay? Oil crisis, we're going to produce less stuff because oil is expensive, and we use oil to to run machines that make other stuff. Recession, we're not really making, people aren't buying as much stuff, so you produce fewer minerals. All right, fewer resources. All right, so just I don't even know why I have this slide in here, honestly. This is under the ocean. Where how do we get minerals? I guess is why I have this in here. This is in here because you can get minerals just naturally. You don't have to mine them all the time. Um, in this case, we've got a little vent in the bottom of the ocean. It's kind of like a miniature volcano that just constantly keeps running. And then this black smoke here, which is not actually smoke, it's just magma cooling very quickly as it hits the water. Um, those are minerals, and then those minerals, of course, just kind of fall around it, and it makes it really easy to just go pick up those minerals. Okay, so what if you can't do that? What can you do to find them? Well, we can do lots of things. People are paid lots of money to go out and try and find these mineral deposits, and they can use aerial photos, which are pictures taken with airplanes. We can use radiation measuring equipment to look for things like uranium, magnetosphere for iron and other magnetic uh, metals, a gravimeter that, we're looking at the density, okay, how dense is the rock, seismic surveys, which are just going out and looking, okay, where are the fault lines? And then, of course, chemical analysis of certain rocks in certain areas. So I can go out, get a rock, do an analysis on it, comes back, tells me, yeah, this thing is full of iron. I can go back to where I found that rock and probably find a lot more iron. All right, so how do we get them out? Once we find them, well, we mine them, okay? So here's one way, subsurface mining. This would be, here's your minerals. Those are these bands of minerals from the rock. And we want to build these shafts and tunnels. Okay, shaft is this way, tunnel is this way. And so you can go through and mine it out a little at a time. Okay. Here are other ways to mine things. All right, we're going to cover all of these ways, but you've got the open pit mining. Okay, both of these are open pit mines. All right, here's another picture of open pit. Mountaintop removal. Okay, just take the top off, and dredging. So, well, let me go back to these. Okay, so how do we do all of these? The open pit mines. Well, open pit mining is what it sounds like. It's kind of what's depicted here. You just dig a hole. Okay, dig a hole into the earth and get it out. Not really complex. Dredging is underwater. You basically take this giant shovel, drop it on the bottom of the ocean, or lake, or pond, or whatever it is, close the shovel, pull it up, put it on a barge. And mountaintop removal. Mountaintop removal is when you just cut the top of the mountain off, okay? So you've got a band of, let me draw here, okay? So originally this used to have a mountaintop on it, and what they did was they cut off all this stuff in order to get to the coal or whatever it is here. So then they're actually just mining the coal. So it kind of becomes like an open pit once you take the mountain off. Okay, so there's lots of things that can happen there. So the implications of this, there's lots of things that go wrong with mining. Obviously you're destroying the habitat. Like nothing's going to live here. This is just bare rock. Um, and then what we call acid mine drainage. Okay, acid mine drainage is a result of sulfur. All right, so let's say that this is my little mining area, and I've got layers of stuff and whatnot, and I go in and I mine out this. Oftentimes there's high concentrations of sulfur near the element, which is locked away in the rock. All right, once we open that up to the air and the water, when you combine water with sulfur, you produce sulfuric acid. Okay, so water and sulfur become sulfuric acid. Sulfuric acid is what you're seeing in all this water. Notice how nothing grows along the banks here. Okay, everything's dead. These trees are dead. It's orange looking, it's gross, it's bad, and it's a real big problem. One of the biggest fields of environmental science is going around cleaning up acid mine drainage from mines all over the world. Um, you know, when you mine out dirt, there's dirt to clean up, so that dirt oftentimes will end up in streams and clog them. Alright, so you end up with clogged streams. And sometimes if you're doing tunnels underneath of stuff, so if we set up our example again, and if I mine all this out, it is likely that all of this land on top of it will settle back in over time. I may not do it right away, but over time. And so if I've got, a highway here, draw in my little car, all right, that car is also going to sink down into it, which is obviously a problem. Um, so as it settles, okay, so you've got like settling here, it's called subsidence, okay. That subsidence generates a high wall. A high wall is kind of just like a cliff. Um, not really something that you want around, these cliffs where you've got problems. So here's an example of why it's a problem. This house fell down into the ground because it's got some sort of mining going on around it or under it. And so it fell into the ground here. Um, and also these spoil piles or gob piles. Uh, this is a gob pile or a spoil pile. Sometimes they're called spoils. Um, that's the stuff that they didn't want. Okay, so you want the ore. Okay, ore is good. Makes miners happy. All right. This stuff is what they didn't want. It's the leftover stuff. It's not valuable. It's just dirt. So they leave it, and it creates these gob piles or spoil piles, and these are what oftentimes actually generate a lot of acid mine drainage. All right. So what else? You know, hazardous problems. Lots of this lake. I don't know why they're swimming in that lake. It's probably full of sulfuric acid. It's not really good. Okay. Again, open pit stuff. Lots of collapsing things. Just waste in general. Subsidence is what I was talking about, where this land fell in. Okay. Um, and yeah, so let's just say let's focus on this one. Uh, yes, there's surface burning, what you're seeing here, um, and then there's vertical openings like that where people can fall in and all of that. Those are not so much of a problem. I mean, they're usually well marked and things like that. This underground mine fire stuff. Let's see. In Pennsylvania, so let me try and draw something that looks kind of like Pennsylvania. Okay. Pennsylvania, there's a lot of coal in Pennsylvania, and I don't remember exactly when, but at some point there was a mine. Okay, let's just say it was up here, and unfortunately, someone set the coal on fire, and so that fire has been burning away at the coal for a very long time, and it's burning across the state of Pennsylvania. The ground near that fire is always much, much warmer. I'm talking like 100 to 300 degrees Fahrenheit. Um, and they cannot put out the fire. I mean, it's just this giant coal burning fire. Basically, they can just try and mine from this end faster than this burns it away. All right. So those are environmental implications. Social implications of mining. You're going to have a large influx of miners. Anybody remember, the gold rush of 1849, right? San Francisco 49ers are named after that. You have a lot of people move in, mine out all the stuff. Uh, well, eventually the mine closes because you run out of gold, and so you get ghost towns. So still in the Midwest and California, you can still see ghost towns. I mean, they're out there where people just left. They're not just something out of the movies. And then, of course, you have all the environmental stuff that comes along with it, which are bad for society. Bad water, change in land use, go from farming to urban because all the people move in, or farming to destroyed because of the mining. Um, and then, of course, poor air quality, dust from the construction, the machines, all that sort of stuff. All right, so away from mining now, smelting. Smelting is just the process that we use to separate the good stuff from the rest of the stuff. So this is ore. Okay, this is ore. It's a rock with a mineral in it. You put it into a furnace like this, and it melts it. When you melt it and you get something that is liquidy, okay, so if I have liquid, the less dense stuff settles out. So you get less dense on top and more dense on bottom. Depending on your mineral, it might be less dense or more dense than the rest of the stuff. But either way, okay, if I want the more dense stuff, I pull it off the bottom. If I want the less dense stuff, I pull it off the top. Here's just kind of I guess, a cycle, okay? We'll start, with the mining, okay? So we do an open face or open pit mine. You collect the ore, you separate ore from gangue. Gangue is spoils, okay? They're the stuff that go into the gob piles. All right. and the ore is the good stuff. So the ore goes to the smelter. All right, the smelter smelts it. You melt it, you make it into something. If you recycle it, you can send it back up here and do this again and again, lots of times. Sometimes people just throw stuff away, and when they throw it away, it goes to the environment. And I'm sure you guys have seen, old cars out in the middle of the woods or something, where somebody just left something, and that's not really recycling it, unless you're waiting for the rock cycle to recycle it, which is going to take a really, really long time. And now for what environmental scientists do, which is land reclamation. Okay, this used to be this. Okay, this used to be a minefield, not a minefield, like a mining area. Um, and they made it into a nice, beautiful botanical garden that's safe for everybody. Okay, and same thing over here. Okay, you can turn uh, land that was really crappy and polluted into really good land with a process called reclamation. It takes a really long time. Um, One of the laws you're going to learn about later, it's called in the pollution unit, it's called RCRA. It stands for resource, okay, resource conservation. I'm not going to spell out everything. Conservation and Recovery Act. Recovery Act. And it's passed by Congress in the 80s. And what it allows people to do, what it allows companies to do, is to voluntarily go into places like this and recover them and reclaim them, which is a good thing. And I've worked on a few sites like these where we're taking something that's really crummy and not useful and turning it into something that's useful. So some things that have happened with laws. Okay, first you had the Madrid Protocol. Don't worry about that one too much. Um, but you do have this one, the Surface Mining Control and Reclamation Act, and also, you'll see it, SMCRA. Okay, something like that. And that allows us to start regulating mining. It used to be, people just go out, they dig up a hole, get the ore that they want, and leave, and they would never do anything about it. Well, now mining companies can't do that. They actually have to go back and do some level of reclamation. So how do you reclaim land? How do you do it? Well, it's really simple. First, you find the land that's destroyed. Then you have to recontour it or regrade it, which means, if I've got land that's really, really steep, from a mine, okay, I might fill it in with some dirt to level it out, something like that. Okay, then you're going to add some topsoil so that stuff will grow, and then you're going to plant some plants. So you get a little tree here, and that's what makes it pretty. Now you'll monitor it for 5 or 10 years, depending on the location. That's a low ball estimate. They'll monitor some places for 30 or 50 years. So as we said earlier, we get more and more resources with we have to mine more and more resources as we have more demand. Okay, you have to have supply to meet demand. Otherwise, prices of like your iPod would not cost $100. It would cost $10,000 because there would not be enough supply to meet the demand. But we do mine more. Okay, eventually, though, a mine becomes what we call economically depleted, meaning it costs more to find, extract, and transport than it's worth doing. Okay, we might have lots and lots and lots of, diamonds out there, but if people stop buying diamonds, then they're going to stop mining them because it's not worth it anymore. And we can lower the amount of mining by reuse and recycle. Aluminum especially. Aluminum is so hard to mine and to refine, to smelt. So by recycling aluminum cans, that really cuts down on the amount of mining that we have to do. Conserve, of course. Drink less stuff out of aluminum cans. Okay, we could find a substitute. Maybe we run out of diamonds. Well, then everybody switches over to rubies or some other precious gem. All right, or most importantly, just go without it. Okay, do you really, really, really need that brand new huge TV? things to think about. So what do we do? Okay, what do we do to meet demand? How do we continue to have really cheap Apple devices? How do we continue to get the latest, greatest, newest smartphone every 3 months? How do we make 20 million iPhones for people every single day? Um, so, well, eventually we're going to run out of the resources. We're going to run out of natural capital and we're going to economically deplete all of it. So how do we deal with it? Well, should we subsidize mining companies to keep the mineral prices low like we do with food? Um, should we mine on public lands? And by public lands, we mean like national forests and Yosemite and Yellowstone, all that sort of stuff. Should we start using low-grade ore, stuff that's not as good? All right. What about mining the oceans? Stuff that nobody owns. Can we go out there and mine the bottom of the ocean? Maybe. So there's lots of stuff to do and think about for the future as we start to run out of things. One thing that we're really concerned about is copper. I mean, people are already stealing copper from people's homes, like stripping their electrical wires and stuff because copper sells for so much right now. Um, in the future, it's only going to go up. There's less and less copper available. So, um, you know, that's a lot about the mining. There's some really good labs out there that you could search for and do at home if you want. One is cookie mining, and the other is cupcake mining. Uh, so if you need those, just contact me. I can send you instructions for how to do those. You just go out and buy some Chips Ahoy and some store-bought cookies and some Ding Dong cupcakes, and you can mine those using like a straw and toothpicks and stuff. And it's a really good simulation for how these companies do things. Um, and you get to eat the cupcake at the end. So it's a good way to show economics of mining as well as just the process of mining. So be sure to Google those. Those are, again, cookie mining and cupcake mining, and take a look at those. Hopefully maybe you can suggest them to your teacher and you can do that as well. All right, so I hope you learned something this time, and I'll see you next time.